This is section 1.3a, measure of center. We're going to look at the mean and the median. The most common measure of center is the ordinary arithmetic average, or the mean. To find the mean, which we're going to call x bar, has the x, the little line on the top of it, of a set of observations, you're going to add the values and divide by the number of observations. If the n observations are x of 1, x of 2, all the way up to x of n, then their sum of the observations divided by the number of observations will be your x bar. Or you can write it as the sum of x of I divided by n. Refer to the data on travel time to work for the sample of 15 North Carolinians. Find the mean travel time for all 15 workers. So this is a stem plot. We would take the 5 plus 10, 10, 10, 10, 12, 15. We would add all of them together and we would divide by 15. If you add all those values together, you should get 337. Divide that by 15, the number of observations. And we would say that the average time it takes for a North Carolinian to travel to work is 22.5 minutes for the 15 people who were sampled. This time we're going to calculate the mean again, but we are going to exclude the person who reported a 60-minute drive because that definitely looks like it's an outlier. So if we do this again, we would add them all together, but this time we're going to divide by 4 instead of 15, and we would get an average time of 19.8 minutes. So one observation raised our mean by 2.7 minutes. The previous example illustrates an important weakness of the mean as a measure of center. The mean is sensitive to the influence of extreme observations. These may be outliers, but a skewed distribution that has no outliers will also pull the mean towards the long tail. Because the mean cannot resist the influence of extreme observations, we say that it is not a resistant measure of center. A resistant measure of center is a statistic measure that is not affected by, or only affected by a tiny bit, by outliers or by data that are not roughly symmetrical. So for this purpose, when we are looking at the center of data, you should only use the mean if your data is roughly symmetrical. If it is skewed left or right, or if there are outliers, you should use your median as your center of your data. The mean tells us how large each observation in the data set would be if the total were split equally among all the observations. In the language of young children, this means the mean is the fair share value, so if everyone gets their fair share. The median, which we'll represent with a capital M, is the midpoint of a distribution. It's the number such that half of the observations are smaller and the other half are larger. To find the median of a distribution, you're going to arrange all the observations in order from smallest to largest. If the number of observations n is odd, the median m is the center observation in the ordered list. If it is an even number of observations, n is the average of the two center observations in the ordered list. Medians require little arithmetic, so they are easy to find by hand for small sets of that data. Arranging even a moderate number of values in order is tedious. However, so finding the median by hand for larger sets of data is unpleasant. Here again is the travel time of the 15 North Carolinians to work, arranged in order from smallest to largest. The count of observations is 15. So if we count in, halfway would be the 8th one. So 1, 2, 3, 4, 5, 6, 7, 8. The 8th one is the number 20. It is slightly bolded in the center. There are 7 observations that are smaller to the left and 7 observations that are larger to the right. So our median is 20 minutes. People say that it takes a long time to get to work in New York State due to the heavy traffic near big cities. What do the data say? Here are the travel times in minutes of 20 randomly chosen New York workers. So the first thing we're going to do is make a stem plot of the data. Make sure to include a key. So for the stem plot, we have the 0s, the 10s, the 20s, the 30s, 40s, 50s, 60s, 70s, and 80s. If you notice on the key, the 4/5 represents 45 minutes of travel time to work. We need to find and interpret the median. So if we look at that stem plot again, there are 20 observations. So halfway between the 10th and the 11th observation would be the median. So if we count, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 behind it, the median should be between the number 20 and the number 25. So to find the median, you would add those two values together and divide by 2. So 20 plus 25 gives us 45. Divide that by 2, we will get a median of 22.5 minutes. The mean and median of a roughly symmetric distribution are close together. If the distribution is exactly symmetric, the mean and the median are exactly the same. In a skewed distribution, the mean is usually farther out in the long leg than the median. A caution, the mean and median measure center in different ways, and both are useful. Don't confuse the average value of a variable, which is the mean, with its typical value, which we might describe by the median. So don't use the word average if you're not talking about the mean. If you're talking about the typical value, that can be any value of the center. But if you say the average, that is referring to the mean itself. For data sets that are roughly symmetric, the mean and the median are both indicators of the center. If the data is skewed or has outliers, the mean is not a resistant measure of the center, so it will pull one direction or the other. The median is a resistant measure of the center, so for data sets that are skewed or have outliers, the median is a better measure of the center. Here once again is the stem plot of travel time to work for 20 randomly selected New Yorkers. Earlier we found that the median was 22.5 minutes. Based only on the stem plot, would you expect the mean travel time to be less than, about the same, or larger than the median, and why? If you notice, this data is mainly in the beginning part, or in the left side, and then it is skewed to the right, and does seem to possibly have an outlier, 85. So since this is not roughly symmetrical, it is skewed to the right, we would expect that the skewness to the right will pull the mean to the right, so we would expect the mean to be larger than the median. Use your calculator to find the mean travel time. Was your answer to question 1 correct? Remember, to find the mean, you're just going to add all the observations and then divide by the total number of observations. So we take them all, add them together, divide by 20, and we're going to get 31.25 minutes, which is bigger than the median of 22.5. Interpret your results from question 2 in context without using the words mean or average. If we divide the travel time evenly among all 20 people, each would have a 31.25 minute travel time. Would the mean of the median and the median be a more appropriate summary of the center of distribution of drive time? Justify your answer. Because our distribution is skewed, the mean would not be appropriate. The median would be a better measure of the center of our distribution.